Yes, class. Is it audible now?
Yes, ma'am.
So who all have joined? Khadija, Mariam Batul, Mariam Muhammad, Rishita, Sidra, Siddiqa, Yahya, and Zaina. All right. So, class, we have completed the applications of Biot-Savart's law. One application was left. But questions practicing was still left, right? 4 to 5 questions, I think we have practiced in the last class. 4 to 5 or only 4? So only
4,
4
ma'am.
questions we have practiced. This was the question where we had left and I asked 4 students to answer, right? But see, class, this needs a lot of practice and now one application is still left. That I'll complete. Then again, we'll do mixture of questions. Why? Because this requires your practice. And this derivation is very important. So I didn't want this derivation to be dealt with the other derivations. This derivation is very important. It's lengthy. It's a little lengthy derivation. And if this comes, you have to write down everything from the starting. You have to make the figure also. And this comes as a 5 marker also. It comes as a 6 marker question also. So basically, it's like if I have this as the circle, right? If this is the circle, and then I am saying this is the, here, this is the periphery of the circle, right? At the center, we have the axis, at the center, we have the axis of the circle. Okay. Now, if I put it like this, so see, this is our axis, right? This is with parallel with the axis. So axis will also be shifted, right? Axis will also be shifted. So instead, this is, you should understand which planes are these. So this is XY plane. So axis is here. Then when you shift it, this becomes the XZ plane with the axis. Now, if I am shifting it like this, right? This is still the axis. And which portion is this? When we are calculating this, this is the portion that we are calculating this in the center. It's basically the centralmost part. Just a second, class. The camera, I think, has turned off. Yeah. So I was saying, if you have the circle present in this plane, then we say this plane is the this axis and then this axis you consider, right? So if you are having two axes, this will be your y-axis and this will be your z-axis, right? So something which is kept in this plane has an axis. When you have shifted it like this, so this is how exactly it will be visible, right? So if this is how exactly it is visible, look here, like this. Exactly, this is what I have drawn. Okay, so basically this was the circle. At the center of the circular coil, you all know the derivation also, you remember the formula too, right? And if we have the axis which is at the center, and we are calculating at the center, so we know that it is directly mu naught I by 2I. But what if I say I want the magnetic field to be here? Then we have to perform another derivation. We have to get the complete form. Clear? Now, what all things you have to remember? You have to remember here that firstly, this is the circle. It has the radius r. This is the axis and it is separated by x distance from this axis. All right. From the periphery, if we extend these two, this is the point where it is meeting. Now, what will this point be? This is r, this is x. So let's say this is small r. This is also small r. Small r will be equal to under root r square plus x square. Here also this is equal to under root r square plus x square. Fine. This is the separation. Why do we need it? We need this particularly because if we take a portion DL, DL is always tangential. Fine. Whenever you are calculating DL, DL is always tangential. Same way here also. This is also tangential. Fine. Now see, this is the angle theta which the current element is making with the radius vector. If this is theta, this is 90 degree, right? Theta 90 degree. This is 90 minus theta. Why? Because when you add all of these, that gives you 180 degree. Correct? So what all, just understand this because this is a little lengthy derivation. So you have to understand the entire meaning of the symbols, right? So see, when we are dealing with the R, small r, and when we are dealing with capital R, the difference that lies here is small r is basically the separation which we are dealing with, and capital R is the radius part. It's actually the radial portion. Yes, class. So small r and capital R, you should know the difference. Small r is basically the disseparation. See, I am calculating it at point A. And if my particular wire is here, so I'll be needing this DL separation to this point, right here. I'll be needing this separation. I cannot use this X separation because my charge is not here. My current is not here. Wire is not here. Current element is not here, right? Nothing is there in the center. I have to use this or this. Fine. Now, understand the diagram well, then we'll be able to do the derivation part is easy. Resolution of vectors and all that will be used. Clear? Now, if you see from this point, the magnetic field will be gone this side. Here, the magnetic field will be gone towards that side. Mean basically pointing towards the side. So theta 90 degree. This is 90 minus theta. This is x. This is dl, which we the 2 points we have taken. This is the center of the circle O, which is making 90 degree to the axis. And this is the radius theta, everything. And r is basically through Pythagoras theorem we have obtained under root capital R square plus x square. Small r and capital R should be differentiated properly. This is the radius of the circle. This is the radius of the radius vector, which we use in Biot-Savart's law. You write the formula, no? Mu naught by 4 pi is equal to mu naught by 4 pi ideal sine theta by r square. That divided by r square, that is this smaller. Okay. Now see, x and everything we have written. Now 90 minus theta is there. This is also 90 minus theta. This is 90 minus theta if I divide it into x and y axis. Basically, this is the x axis. Here we have the y axis. So if we divide it on the basis of x and y axis, then total is 90 degree. This total is 90 degree. 90 minus theta I have taken. 90 minus theta I have taken. Plus whatever is this x. Let's say this is some x. This angle is some x. This is equal to 90 degree, right? Look, 90 minus theta means this angle 1 plus, let's say this is x for now. So plus this x is equal to 90 degree. So x is equal to 90 minus 90 plus theta. 90, 90 cancel, x is equal to theta. So this x is equal to theta. That's why this theta has been written. I'm erasing this. Okay. So this is theta. Again, we have this, if this is 90 minus theta, so 90 minus theta, this is theta, 90 minus theta, 90 minus theta, and so on. This will be the, so tell me, figure is clear to all of you now?
Yes, ma'am.
Others?
Yes, ma'am.
Yes, ma'am.
Good. If you've understood the figure, derivation is not difficult. It's just that you have to draw this diagram and draw it properly with the help of scales. Because already you have so many things written. You can see I have written already so many things. Now I have to perform the resolution of vectors also. Why? Because DB, both the DBs from both the corners, they are towards different random directions in random planes. Basically, they are in planes. They are not pointing towards any axis. They are in XY plane. Other one is X and negative Y, fourth quadrant, right? Like this we have. So we have to resolve the vectors in X and Y plane, along X and Y. That is the task. So that will also be written. Already this is a lengthy derivation and this cone forms at the end and X and Y axis and huge diagram it is. So instead of drawing the things with freehand, I would suggest to all of you that draw properly with the help of scale. Draw the circle. Freehand, obviously, you cannot draw this because you are showing it in the YZ plane, right? YZ plane, remember this is in the YZ plane. All right. If this is in the YZ plane, draw these axes, the main axis properly. This is the main axis. Draw this properly, the separations properly. And whenever you are writing the derivations, you have to write everything. Let us consider a circular coil, circular loop, which is present in XY plane, having the radius R. The axis, the point of calculation is separated from the center by X distance. Like this, you have to mention the whole story thing. I have seen in most of the papers, very few students write this. Class, your marks will be deducted. Why? Because for you, R is the radius. Radius has no particular meaning that it will be denoted through R only. It can be denoted through A. Radius can be denoted through B letter, any letter. So it's not necessary. So if you have taken it as capital R, you should specify that your capital R is the radius. And especially in questions like these, where radius is also mentioned, where the separation radius vector in the formula is also taken. So it becomes difficult to identify which one is correct. So it's better straight away first, before even drawing the figure, mention everything. Or you can draw the figure and then mention all the things. Fine. So in this figure, I hope everything is now clear, because it looks a little complicated, but it is not, right? You can see these are just two ends which have been taken to draw the magnetic. Now see, if I resolve this, suppose this magnetic, this one will become dB cos theta. Perpendicular one will become dB sin theta. Look at this one. If I resolve this, this will again become dB cos theta. Perpendicular one downwards will become dB sin theta. Now class, this is just for two opposite points which I have taken. Look, if this is the circle, I have taken 1 point from here. So diametrically opposite end I have taken. One DL from here, other DL from here. समझ रहे हो ये चीज? सी दिस इज द सर्कल के दो ऑपोजिट एंड से, जो पेरिफेरल की तरफ जो एंड्स है, वहां से जस्ट दो पॉइंट्स ली, दो डायमेट्रिकली ऑपोजिट पॉइंट. डायमेट्रिकली ऑपोजिट पॉइंट का मतलब क्या है? 1 point from one end, and if you join the diameter, the other point which you will reach this. All right. So these are the two diametrically opposite ends. These have been, one axis is in the center. Their magnetic fields where they are crossing is taken. This is on a point, particular point like this. This is what we are studying. At this point, I want the calculation to be done. Let's name it something. Let's name this point as A. ताकि थोड़ा point का difference याद रहे. Let's say this point is A. So here the point A we are calculating. Now we have resolved the vectors also, dB sin theta, dB cos theta. Now the thing that I want to tell you is, if these two diametrically opposite ends have this story which we have discussed till now, what about the other ends? Same thing or not? Same thing. Even if I rotate this, if I just shift this and I take two diametrically opposite ends from here. Look, if I take from this, if I take 2 points, one from this and other from this, and then one from this and other from this, then one from this, other from this, one from this, other from this. All of these are diametrically opposite only. All these can be taken, right? We can take any of these. What will happen ultimately? All the cos thetas will be pointing in the same direction because of all the current elements which we have taken from diametrically opposite ends. And all the dv sine thetas will be cancelling each other. One is towards other side, one is towards the other side. So this dv sine theta will cancel this dv sine theta, right? So similarly, all the other types of dv sine theta which are formed due to the diametrically opposite ends, they will also be cancelled. So all the dv sine thetas will be cancelled and all the dv cos thetas will be pointing towards one end. That is what is necessary, and this was all major which you should know. Now is just simple formula writing, derivation writing, which you will be able to do. You should know why we are now, what should be the next step. Along y-axis, even towards the net, by. By is basically db sine theta. Integral of db sine theta means all the db sine theta towards one side minus integral of same db sine theta means db sine theta form towards the opposite side. They'll cancel, by will straight away be 0. Straight away this by will be 0 because all the magnetic fields which are present, all the magnetic fields which are present due to the y-axis or along the y-axis, they are equally distributed on one side and opposite side. And they'll be cancelled because they are moving the other direction. Because they are in the other direction, that's why. Okay, so by will be 0. Now come to bx, that is x-axis. Look class, along x-axis, all the cos thetas will be pointing towards one side only. So this is basically integral of dv cos theta. All right, this is the integral of dv cos theta. Now you know what is the Biot-Savart's law, mu naught ideal sine theta by 4 pi r square. That is your dv. Theta, here it is 90 degree, which is formed by dl and r, which we have marked also. So mu naught I dl sine 90 degree divided by 4 pi r square, right? So this will be db is equal to mu naught I dl divided by 4 pi r square. Fine. Now, this is just db. We have one more thing now. Had this been just with the magnetic field, this would have been our answer. But the issue that here is with this cos theta, right? Cos theta also we need to solve. So tell me from the triangle, I'm showing you the figure, what is the value of cos theta? Answer in the chat column. Everything is written in front of you. X, capital R, small r. What will be cos theta? This is theta. Quickly, in the chat column, all of you. You people do not know the basic trigonometry. Okay, Rishita, your answer is right. But what about the other students? Cos theta you can't tell. I'll wait till all the students answer. Khadija, Mariam, Batul, Sidra, Siddiqa, Yahya, Zaina. Okay, Zaina has also answered. Theta is given. Theta is this. Cos theta you people have to tell, and that you people are not able to tell. Yes, other students, your answers. If you can't answer this, then there is no point of this lengthy, big derivation. If cos theta you people can't tell. Yes, yeah.
1 minute, ma'am. I'm just typing.
Okay, Mariam has answered. Mariam Mohammed has answered, right? Okay. So, Mariam Mohammed and Rishita, you both have the correct answer. Other students, where are your answers? I'll wait. Solve it. Take the entire class. Take 1 hour. Take 1.5 hours. How much time is left? Take it. Tell me cos theta, because you need a lot of time for the calculation of cos theta only, no? Tell me. Sidra is never answering in the class. Siddhika also has stopped answering in class 12th. In 11th, she was answering. या cos theta के लिए कितना time चाहिए?
Sorry, ma'am.
Khadija,
I'm finding the right words.
what?
I was
Zaina, yes,
finding.
now answer is right. Zaina, now the answer is correct. So Zaina, Mariam, Rishita, 3 students have answered. Rest of you can leave the class. Yes, Yaya, what was your excuse which you were giving? Yes, Yaya, you were saying something. I interrupted you. Triangle is there. Okay, Yaya. Slight error is there. Just check again. Check your answer. Slight error is there. Zaina and Rishita and Mariam have answered. Yahya has also tried. Siddiqa, Sidra, Mariam Batul, Khadija. Your answers. Cos theta, I'm asking. A simple triangle has been given. This is the triangle A. This, you can name these points also. This is O. Name this as Z. A, Z, O. This triangle is there. This is theta. What is cos theta? Okay, take a minute. Okay, Mariam, take a minute. I'm waiting for a minute, giving you a minute, but tell me. What took you so long, Khadija? Answer is right. But cos theta and all should be on your tips class. Today you all will study trigonometry. From your class 10th book, you can take the PDF. PDFs are available on the internet. Introduction to trigonometry was there in your class 10. There was a table about cos theta, sin theta, and tan theta. How sin theta is constructed, how cos theta is constructed, how tan theta is written. Like, yeah, now answer is right. Mariam, your time which you have taken, Mariam Batul, it's still going on. Mariam Batul, so 3 students could not answer this. Sidra, Siddika, and Mariam Batul. 3 students. So if you people do not know your 10th standard, that I cannot teach you. You didn't know vectors or you were having doubts in calculus, that I had taken again also. Though that was a topic from your class 11, but still I did that. And that can be done again also. That also I've told you. But class 10th, I cannot teach. If you still need help with class 10th portions, then text me personally. Your classes will be arranged. 1 or 2 extra classes will be required just to brush up your basic knowledge if you are lagging. So just secretly comment, although anyone who wants those classes are wrong. Answer is wrong. Trigonometry, you all will study today. Cos theta is basically capital R by small r. How? Cos theta is base by hypotenuse. Class, you have to remember this. Sin theta is equal to perpendicular upon hypotenuse. Cos theta is base by hypotenuse. And since tan theta is the ratio of these two, so it is perpendicular upon base. This you have to remember along with the value. There's a table which has 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Yeah. Sine values, cos values, tan values, cot values, all these are written. So like sine 0, this is half, 1 by root 2, root 3 by 2, like this, all the values here, everything. This is the table. This table and this table. Without this, see, the derivations you can learn, but the question will not be able to solve. Okay, so this is very important. All those who took time to answer, I think except Rishita, nobody could answer quick and correct. Everybody has taken time. So cos theta is basically r by smaller. So instead, so dB is ready, cos theta is ready. Did you understand this cos theta part? Look, this is the base of the triangle, right? This is the angle. So this will be the base, na? This is the opposite side. X is the opposite side. So R will be the base. And longest, the slanting side is obviously the hypotenuse. So capital R by small r. So all those who have answered capital R by under root R square plus X square, their answers are right. How can you take X by this? X by R is not taken. Capital R by small r is the correct answer. So all those who have answered, all those who knew, it's good. But all those who do not know, please revise. In the next class, then I'll straight away ask you all wherever this cos and sine come, because other derivations are also left. See, you have Ampere circuital law, magnetic Lorentz forces there, forces are present, conversion, you will get the trigonometric values. Even if not in this chapter, in the other chapters you will get. So net magnetic field is dB, this is cos theta. So dB cos theta. So class, if we write all the constant terms together, mu naught I capital R by 4 pi, this becomes R cube, and integral of dl is left. So this is mu naught I R by 4 pi R cube, and since it's a circle only, so it will be 2 pi capital R. Why capital R? Because radius of the circle we are taking. So pi cancel, this is 2, this is 2. So mu naught I R square by R cube, right? 2R cube. We are left with right now mu naught I R square by 2R cube. What was the value of R? Under root capital R square plus X square, right? So ये हो जाएगा, if we put the value, this will be mu naught I capital R square, तो ठीक है, by 2. This is, see, this can be written as R square plus X square to the power half. And further is the cube. So we can write R square plus X square to the power 3 by 2. This is the magnetic field, where on the axis of a circle. If n number of turns are there, you can multiply this with n. For n, you can write the number of turns as n. So it will become n mu naught I capital R square by 2 capital R square plus x square to the power 3 by Lex. Write down this derivation. In between, if you have any doubts regarding even this cos theta or any portion, please ask and text. Write it from here. Yes, class, your answers. Many students have not answered. See, let me discuss it now. See, you have two rings, right? Again, both are in different planes. If you have one ring present like this, other is present like this, right? And then at the center of both the axes, you have to find out the magnetic field, right? So first, second. So net magnetic field, again, we'll be calculating in the same manner, B1 plus B2. Come to the first one. What is the radius? What is the axis separation? This is the axis separation X. This is the radius B, right? So in our formula, we have B is equal to mu naught I capital R square. Radius is B, so B square by 2 capital R square means the radius square plus X square to the power 3 by 2. Fine. Now see right hand thumb rule for the direction. This is like current is going inwards and then coming out from below. Going above, coming down from below. Like this, right? Right? So see, if current is going inside, so inwards curl. Thumb is pointing towards the negative x-axis means minus I cap. So this is minus I cap plus. Second one, this is mu naught I a square. Now radius is a square to a square plus x square to the power 3 by 2. Now see, how will you write down the direction? Current is going from this part is the current is going here, and from backward it is going to the left. So it is coming like this and going like this. So current is basically moving like this. Thumb is pointing upwards. That is J cap. So if this is J cap, now see if you get the values, you can substitute common things you can take out and further you can solve this. Okay, Zain, I'll show you. First, write it down. Write down this part. Wherever you have left this space, I'll show you. Write it down, all of you. I hope all those who have missed the derivations portions in between, they have copied it. If anyone still wants me to show any portion of the screen, please let me know. Otherwise, you all can start leaving. On Thursday, I'll continue. On Thursday, we'll practice numericals from this. So please revise this part and come, because I'll be asking you all. All right, revise and come this portion. Okay, thank you so much, class.
Thank you.